Welcome back. In this video, we will discuss about the process kernel handle table. But before that, let us understand what is a handle. When operating system allocates the memory in kernel to manage the kernel object, in that case, this memory area has a base address like any other memory area allocated. But this memory area is never returned to any process when the kernel object is created using the respective Windows APIs. There are few Windows APIs mentioned here using which you create the different kernel objects like create semaphore for the semaphores, create mutex for the mutexes, and create event for the event kernel objects. The memory is allocated against the kernel objects, and this memory area is never returned to the process when you use the handle or you call these functions. The process which calls these APIs maintains the information under a process handle table that we will discuss on the next slide. The handle value which your process is able to see is the index in this table where the information regarding the kernel object has been maintained. This handle is never an address value in any memory area. Now let us discuss about the process handle table. Process handle table looks something like this. You can see there is an index column. You can see there is a pointer to kernel object memory block, but you never get an access to this pointer. This process handle table is created after the initialization of the process. Operating system creates and manages this table. This process always gets the index and not the pointer to kernel object memory block, which means whenever a process handle table is created and you have an object created for the kernel object, then in that case, the handle with respect to that kernel object will be returned to you, and that will be the index of this table and not the pointer to memory block. This is done to keep the kernel memory safe from getting it accidentally tampered. And this image I have taken from the Jeffrey book on the Windows programming. Now let us discuss about the lifetime of process kernel handle table. The handle to kernel objects are closed by the close handle API calls. When you call the close handle API, then it decreases the usage count by 1. When the close handle call makes the usage count as 0, then the entry will be deleted from the table index. It may be that your close handle call has not decreased the count to make it 0. So in that case, the kernel object will not be deleted, but the handle will remain there. So for proper maintenance and efficient use of kernel objects, close handle should be called properly in code. What if the kernel handle not called appropriately? What will happen if you forget to call the close handle API call after your kernel object gets out of scope? In that case, when the application gets unloaded by the operating system, then process kernel handle table will be cleaned up by the OS itself. While cleaning up the process kernel handle table, OS will remove all the entries in the table, which we discussed on the previous slide. OS itself deletes the kernel object if the usage count becomes 0. So after each call on the close handle, the usage count will keep getting decreased. And once the usage count becomes 0, the operating system will itself delete the kernel object. That's it.